Good evening to everyone. We're going to present our prototype called Hydrosafe. This system was created in response to the growing water scarcity problem in agriculture, where efficient irrigation methods lead to unnecessary waste. Our prototype used soil moisture sensors and an automated control system to deliver water only when the crops truly need it. This approach helps reduce water consumption, improves efficiency, and supports global sustainability goals. Through this project, we aim to show that accessible technology can make irrigation smarter.
Context of the problem. More than 40% of water destined for agricultural irrigation or green areas is lost due to factors such as evaporation, leaks, pipes in poor condition, inefficient irrigation techniques. Manual irrigation or the use of traditional systems affect the yield of crops such as soil quality. Against this, automatization through moisture sensors becomes a key tool since it allows watering only when necessary, avoiding excesses and reducing waste. In this scenario, Hydrosafe represents an accessible, functional, and real database solution capable of optimizing the use of water in gardens, cool gardens, and small crops. We propose as a solution the development of Hydrosafe, an automated irrigation system controlled by soil moisture sensors and managed by an ESP32 microcontroller, thus avoiding water waste due to excessive irrigation, poor programming, or inaccurate manual intervention. Our project incorporates protection and scalability elements, which enable it to learn and adapt to the environment.
Justification and feasibility. The viability of Hydrosafe is based on several key factors. Its efficiency allows for saving up to 50% by watering only when soil moisture is low. The system helps preserve soil and local ecosystems by preventing overwatering, erosion, and nutrient loss. Justification of viability. The project is economically accessible because it uses low-cost components such as the ESP32 and easy-to-get compatible sensors. Its automation eliminates human errors and guarantees a more stable and accurate water supply. Justification of effectiveness. The effectiveness of Hydrosafe lies in its ability to regulate irrigation according to the actual needs of the soil, eliminating the uncertainty of manual fixture-scale irrigation. The capacity sensor detects the minimal changes in humidity, activating the saline value only when the substrate actually requires it. Also, the foundation of effectiveness is that the flow sensor allows you to quantify the water used. The microcontroller offers speed, stability, and responsibles to change in the environment.
Description of our prototype is an automated system that measures soil moisture in real time using a capacitive sensor, preventing corrosion and providing more stable readings. The SP32 receives the data and controls the relay module that activates one solenoid valve, which allows or stop the flow of the water. The system has a YFV10 flow sensor that records the volume of water used during each irrigation system. The water is distributed by means of a drip hose, complemented by a filter and pressure regulator that ensures a constant and equal flow. All electronic components are protected inside an IP65 waterproof box, allowing safe and durable use. Its modular design facilitates future improvements such as adding wireless connectivity or data storage.
Okay, so the table of variables is first the humidity in the soil that is dependent and is the humidity level detected by the sensor. Then is the time of irrigation that is independent and is in minutes. Is the duration of water flow controlled by the relay. Then there is the flow of water that is dependent and is by liters per minute. That is the amount of water passing through the solenoid valve. Then is the level of battery that is controlled in volts and is the energy available to power the system. And finally is the ambiental temperature that is controlled in Celsius and is the influence on evaporation and soil moisture.
Our prototype works using an Arduino with a pre-established code. We process the information of a soil moisture sensor. When the moisture level is low, the sensor sends a signal to a relay that activates a solenoid valve, opening the water flow and allowing the soil to be irrigated.
The prototype is expected to demonstrate significant reduction in water consumption compared to manual irrigation methods or traditional systems. This is because the sensors allow for an estimated potential savings of 30% to 60% of water in a small-scale crop cycle, depending on the type of plant and environmental conditions. Likewise, it is anticipated that the plants will show improvements in their health and development. At the same time, the records obtained through the flow sensor will provide objective data on the prototype's performance, allowing for a comparison of actual water consumption with other methods and providing clear evidence of the system's effectiveness.
Well, finally, we have that Hydrosafe connects to the STEM areas. First, in science, use principles of soil science and plant biology. By measuring moisture levels, the system helps us understand how water availability affects plants' health and growth. In technology, the project incorporates digital components like soil moisture and a microcontroller that process the data. This allows the irrigation system to operate automatically and efficiently. Next, in engineering, Hydrosafe required the design and assembly and testing of a functional prototype. We had to organize the structure, choose materials, connect circuits, and refine the system to ensure stability and accurate readings. Finally, in mathematics, the system works with numerical moisture ranks, percentage, and thresholds. We interpret the data to calculate water savings and compare results before and after the prototype is used. Overall, this table shows that Hydrosafe integrates every part of the STEM.